Welcome to The Explainer. So today, we're unpacking what might honestly be the most fundamental shift in software development we've seen in decades: Anthropic's Claude code and the move toward agentic coding. Look, if you spend your days deep in codebases, or even if you just work alongside engineering teams, you already know AI has been making some serious waves. But what we're looking at today, it's not just another upgrade to your standard coding assistant. It's a total redefinition of the relationship between us, our tools, and the software we build. Let's dive right into this massive paradigm shift. The core idea here is that the tools engineers use to build software are now capable of building software themselves. For the entire history of computer science, our tools have been exactly that, right? Just tools. Passive instruments waiting for our exact keystroke by keystroke commands. They assisted, sure, but they never really initiated. Well, that dynamic is completely flipping. The tools aren't just assisting anymore, they are actively building. And as we go through this explainer, you'll see exactly how this shift from passive tool to active builder is playing out in the real world. Now, we really need to draw a hard line between Claude code and those standard code completion tools you might already be using. Those older tools, they're hyperlocal. They suggest the next line, maybe a function if you're lucky, while you micromanage literally every single step. Claude code, on the other hand, operates at the project level. It doesn't just guess your next line, it reads the full code base. It plans an approach that spans multiple files, it executes those changes, runs the tests, and actually, here's the real kicker. It iterates on its own failures. We're talking about a move from line-by-line autocomplete to full-on project-level automation. You set the goal, you review the result, and you stop steering the ship every single inch of the way. So the absolutely crucial point here is understanding the word agentic. You're going to hear this term a lot. An agentic system is entirely different from standard conversational AI. Your standard AI responds to one prompt at a time, right? Just a basic back and forth. But an agentic system acts toward a broader goal with a significant degree of autonomy. That means the system independently works toward an objective that you set, making decisions and taking actions along the way without needing you to hold its hand for every single little task. Let's break down how this structured autonomy actually works in practice with the agentic execution loop. First off, it reads the codebase to build context and understand how all your modules connect. Second, it plans a sequence of actions. Third, it executes them using real development tools. It actually uses things like the GitHub CLI natively. It runs the right commands with the exact right syntax so you don't have to go look them up. And fourth, it evaluates the results and adjusts its approach if it needs to. You, the developer, set the objective and keep control over what actually gets committed, but that execution loop, it just runs independently and does all the heavy lifting. And honestly, this elevates human engineers in a really profound way. There's always this fear floating around that these tools will replace developers, but the reality is basically the opposite. When the majority of the raw code is being written by an agent, engineers don't disappear, we level up. We become architects and orchestrators. Instead of getting bogged down chasing syntax errors, your brain power is freed up for high-level product thinking. You transition into managing multiple agents in parallel, giving strategic direction and making the big decisions that actually shape the product. You're moving from the assembly line straight to the control tower. Let's look at how this builds a massive advantage by automating the deep, complex, and frankly, tedious parts of the job. Navigating unfamiliar code used to mean days of tracing dependencies or, bothering senior engineers to explain a 5-year-old legacy module. Now, Claude Code searches directories and traces those dependencies for you, getting new team members up to speed in minutes. It can execute massive multi-file refactors that would normally swallow entire sprints. It uses CLI tools natively, but honestly, the absolute biggest headache saver of all is how it handles testing. Look, dealing with continuous integration failures is universally exhausting. We all know that feeling. But imagine just not having to manually chase down those errors anymore. When tests fail, Claude Code literally reads the errors from your CI pipelines, whether that's GitHub or GitLab, figures out what went wrong, writes the fix, and then runs the test suite again. The execution loop just keeps running until everything is green, and then it commits the fixes automatically. It takes the most frustrating momentum-killing part of the job and handles it quietly in the background, leaving you free to focus on the next big feature. Section 9, Democratizing Development. Anyone with an idea. Let's look at how this technology opens the door for entirely new builders, not just seasoned engineers. It's one thing to talk theory about agentic coding, but look at how real companies are actually changing the way they work right now. Stripe deployed this across over 1,300 engineers. One team did a 10,000-line Scala to Java migration in just 4 days. That was estimated to take 10 engineer weeks.
Rakuten, they brought their average delivery time for new features from 24 working days down to just 5. Their engineers are running multiple Claude code sessions at the exact same time, basically delegating tasks across the entire codebase simultaneously.
Just think about this number for RAMP, an 80% reduction in incident investigation time. That is a staggering improvement for system reliability. But maybe even more fascinating, because of this democratization we just talked about, RAMP's non-engineering teams like sales, risk, and finance are now querying their data warehouse using plain natural language. They're pulling the data they need instantly without writing a single line of SQL. No way could they do that before.
And then there's Wiz. They pulled off a massive 50,000-line library migration from Python to Go in just 20 hours of active development. Let me repeat that. 20 hours for a task originally scoped for 2 to 3 months of manual work. Just think about the budget, the resources, and the human energy saved there. That is the raw power of a system that can read your codebase, plan the architecture shift, and execute it across thousands of lines, totally without fatigue.
Seeing that kind of speed and scale, you're probably asking yourself this exact question right now. Who actually maintains oversight, right? If an AI is running terminal commands and rewriting 50,000 lines of code, how do I know it's not going to break my entire system or push something it shouldn't? Trust and safety are absolutely critical when you hand over this much autonomy. Well, the answer lies in strict access boundaries. Anthropic designed Claude code with a cautious default. The system requires explicit permission before modifying your files or running any commands. It doesn't just operate in some opaque backend where you can't see what's happening. It works right within your existing environment. You have the power to define its autonomy. You can approve every single action manually, or you can rely on built-in classifiers that automatically distinguish safe actions from risky ones. But ultimately, the decisions about what code actually ships remain entirely with you, the orchestrator.
As we wrap up this explainer, I really want to leave you with this final thought. We are stepping into an era where the barrier to entry for building software is dropping dramatically, while the ceiling for what a single engineer can accomplish is skyrocketing. The tedious execution is getting automated, leaving us with the pure, creative work of designing systems and solving real human problems. So, in a world where your tools can handle the heavy lifting of writing the code and you are elevated to the role of the orchestrator, what ambitious idea will you build first?